So BIM execution plans, as you can see on the screen, these have become a necessary evil. They probably should be part of a more broader design management strategy or construction management strategy, but they've become a requirement in all the specifications. And in principle, they should really start at the beginning of the design process. So the document I share with you, there's a request for the contractor to come up with a BIM execution plan within 30 days of the contract, blah, 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 blah. In reality, there should have been a BIM execution plan from the very beginning of the project. So the architect, he was normally the first one appointed, should have developed a BIM execution plan at the beginning. And that execution plan should then have been taken over and developed by the contractor going forward. So it seems to me a little bit crazy that the particular document I sent to you was starting from zero. So essentially, a BIM execution plan should identify who's on the team. Now, this is not the BIM team, this is the entire team. So who are the architects, who are the engineers, who are the consultants, and it should even get into naming key people. So who's the principal architect, who's the registered structural engineer, et cetera, et cetera. The execution plan must define the roles and responsibilities of all the different participants. And that's not the BIM manager's roles and responsibilities, that's the design team's responsibilities and the construction team's responsibilities in relation to BIM. So essentially what we're trying to do is we need to reskill existing and well understood roles to be BIM competent and BIM capable. So if you are a project manager, you should be able to use a tool like Navisworks or another viewing platform. You should be able to navigate around a 3D space, and you should be able to interrogate that space. You don't have to create the space. You don't have to fix a problem in the space, but you should be able to navigate in that space. And there are any number of ways of doing it. So you can use Navisworks, you can use online viewers, you can use executional files, it doesn't really matter, but you need to be looking at the models. There should be communication, collaboration, coordination procedures, which is basically the common data environment. So how do you share information? There needs to be a definition of what software is being used. Unfortunately, a lot of the software is version specific. So for those of you who've used Revit before, you will know that if you have a Revit 2018 model, you can open that in Revit 2020. But if you have a Revit 2020 model, you cannot open that in Revit 2018. So it is very version specific, and that needs to be managed. So that needs to be covered in the execution plan. All of the methods for doing model and data sharing need to be covered in terms of how you're going to link files, how you're going to share files. And then you need to cover out all the standards and guidelines and the uses and project deliverables. So essentially, this is a management plan for any project. If you were doing any kind of project, you would have this kind of management plan. Who, what they're going to do, how they're going to collaborate, what technology they have, how they're going to share information, and what standards and guidelines they're going to follow. So a BIM execution plan is no different than any other management plan. So you can look at this diagram here, which I've stolen from Arup, and essentially, this is Arup's internal workflow for how they develop an execution plan, and it covers all the phases of the project. So you go from the client starting the process with their requirements. There's a bid stage when the consultant is actually tendering. So they should actually have a checklist, and they should have a pre-contract execution plan. So a good consultant will already know how to respond to the clients that need BIM or want BIM. Once they're actually appointed, this is this idea of a post-contract. This is the actual project. This is not post-project. This is the contract appointment. There's an actual execution plan for the project. There's a delivery checklist, and there's a closeout and handover checklist, handover being to the contractor. So they do their concept design, they do the technical design, and they support construction. Arups, being Arups, have a lessons learned flowchart, and then ultimately they're handing over information for asset management to hand back to the owner. So this is one consultant's way of doing it. I've listed down here what are the key essentials that you need to have in one of these documents, and I've broken it into 3 columns. So the technical side is the software, the coordinate systems, the level of development. You guys talked about LOD. If the LOD is not covered in the client specification, you can put it in the BIM execution plan if that makes people happy, and all the training requirements. You can see that the management is the longest list. So one of my friends in Hong Kong once coined BIM as best if managed. So it's a process that needs to be managed, and that requires resources. And the question I posed to you in the first breakout, nobody actually identified the human resource as a key issue. So you need to have enough people who can manage the process, not just about making models, but actually managing the process. So you have to have coordination processes, collaboration processes, health and safety and construction processes, compliance plans, and a delivery strategy for asset information. And then most importantly, a commercial strategy. You need to understand what the purpose is, what the deliverables are, what you have to deliver in terms of data, what assessment is required, what the effort is going to be compared to the fee that you can charge, and what specialist staff or resources you may require. So if you have a complicated roof like you have on the roof of the West Cowlin Terminus high-speed train station, you're going to need some very specialist operators to be able to handle that. If you're building a multi-story car park with some research labs, you may not have to do it. So again, the complexity is an issue and you may need to allow for specialist staff. So what we're going to do now is quickly go through a process that we use for doing coordination management as a management contractor. So this process I'm going to show you is actually being developed by Rahimi, who's this very tall, handsome gentleman here. He's from Malaysia, and his colleagues. And you can see here, they're actually at an exhibition in Malaysia, and MMC Gamuda are actually featuring their work in the actual exhibition. So we're actually at a major exhibition run by a government agency, and we're promoting our building information modeling resources and reporting our drone captured spatial information portal. And there you can see FISA. So these are the people doing the work. And again, Gamuda as a business is actually putting them in the public space and letting them show off to the industry what they're doing. So they're not putting salespeople out there. They're not putting fronting up people, marketing people. They're putting the actual engineers and technicians in front. So we see BIM as a collaboration enabler. You can see this diagram popping up again, this idea of a central single source of truth. So when it comes to models, we want all the models in a single location. So you can either use ProjectWise, you can use Aconex, you can use Viewpoint for projects, you can use BIM 360. It doesn't matter what the platform is, as long as everybody's using the same platform. So we want to make sure that all the design changes are always visible to all the team members. So we don't want to have a situation where we've got a architectural change that's been talked about for weeks and weeks and weeks, and no one's seen any evidence of it. And then all of a sudden, there's a whole big upload of models, and every 4 weeks, 6 weeks behind schedule. So we want to see continual updates of information. So here's the diagram that we had for this project, the MRT project. And we have basically the idea of BIM coordinators working in all these different disciplines. And you would have seen that echoed in the documentation I shared with you. And so every different discipline or company or firm or subcontractor or whatever way you want to describe it, they have their own coordinators and they share their models to the central file. Everyone can access and reference every model on the CDE. So there's no limitations. The only limitation is you can only upload your model. You can download everybody else's model. So you cannot overwrite, the architect cannot overwrite either deliberately or by accident any other model. They can only upload their own files. So we do spatial coordination, and it's become known as clash detection, I guess. This is the single biggest benefit of BIM in that we can identify problems and resolutions. So this idea of BIM is that it enables early decision-making and resolutions for design and construction clashes. If we can solve the problem in the model, then we can reduce the waste in time and effort and avoid abortive works on site. If the problem is in the model and it's not solved, well, then it's going to be a problem on site. So our attitude is, let's find as many problems in the model as possible. Let's get them fixed, and let's get them fixed before we start construction. There is greater certainty that the design is coordinated and design documentation is consistent. That is only true if the design documentation is coming from the models. If you have been involved in, or you're going to become involved in a project where you suspect that the consultants are doing 2D drawings and retrospectively or later making models, then you are never going to get a model that's consistent with the drawings. The drawings and the models will never match because the people that are generating them are doing it for 2 different purposes. So you need to make sure model first and draw second. If you use BIM and do coordination properly, you can reduce the number of RFIs from site, and you can reduce the site coordination problems. It all comes down to doing this work as early as possible. There is no point doing clash detection when the construction process is halfway through. If the concrete frame for a building is up, then you can forget about BIM. It's a waste of time. If you've only started doing foundations and you've got 6 months of foundation works, then you have a great opportunity to use BIM to solve lots of problems. The reduced construction costs is through reduced changes during construction. So there's likely to be fewer claims, fewer disputes, and fewer conflicts. If this is being used properly, and if the client is being responsible, if they make changes to solve coordination issues, they're still viable variations, but we don't have to wait till we actually make them up on the site. We can solve them, and it'll be cheaper to solve them in digital space. So this is a coordination process. I'm going to zoom into this workflow. I've used the diagram of a washing machine deliberately. This is a process that goes around and around and around and around and around and around. And so it's basically an iterative process. It's also a process that once you've been through it a few times, you may well feel like you've been in a washing machine for an hour or two. So the process is quite straightforward. You start off with, and you develop a specific model for a specific discipline. So it could be architecture, structure, MEP. That specific model is shared on the CDE. So you can actually get that model shared to everybody else. You have a BIM coordinator or a BIM manager. They make sure that all the models are available. If there's any missing, they go back and find the missing ones. And then they do their coordination review or clash analysis. And they prepare a virtual design review issues list. So they prepare a list of issues that have to be discussed at the next meeting. Then you run a 2-hour meeting. So you run a 2-hour VDR. Oops. So you limit the time, because that's about as much time as you can keep people focused for. So you do a 2-hour session and you resolve all of the identified design issues, or as many as possible. And then you share a report of that discussion using Navisworks on the CDE. So everybody can see what was discussed and everybody can understand what's happening. So one of the things that we did on this project was we had a schedule. So there was so many stations across the project with multiple design teams. Basically, we set up a schedule that every Monday, the same stations were discussed every 2 weeks. So if you were working on, for example, Tidiwangsa, you knew that on Monday morning at 9 o'clock, you had to go to a workshop, and every Monday thereafter, that was the workshop you were going to for Tidiwangsa. And that was the same schedule all the way through. Whenever there was a holiday, the meetings would get pushed to the following week. So in certain circumstances, there might have been a week between the meetings, but for most cases, there was 2 weeks between the meetings. So that 2-week gap was enough time for the designers to continue their design, for them to collaborate and share in between and make sure issues were resolved. So this goes back to BIM management. This goes back to managing the team with a schedule and saying, we want to meet every 2 weeks on these dates and we want to run a workshop. And this is what the workshop would look like: a small group of people that can make decisions. So in this room, the guy in the yellow shirt is the client. The guy in the blue shirt is the coordinator for the contractor. This is the mechanical engineer. This is the structural engineer. This is the BIM operator. And this is the architect representative. And they're looking at a particular issue in one of the stations, right? So you can have a small group of people, and you can see some of them have got notebooks, some of them have got laptops, some of them have got iPads, but they're all looking at a model on screen. So the crucial part is it's a model-driven process, and the model is the be-all and end-all. Not a whole bunch of drawings, not a whole bunch of sketches, not a whole bunch of markups, the model. If it's not in the model, it's not being discussed. So some examples that you find in the early stages. So you can see here pipes clashing with ducts. You can see electrical systems clashing with staircases. And in this case, what's happened is in this area, the electrical consultants have misinterpreted the drawings and not realized that this is actually a escalator well in the station. So again, you can see these problems and going, oh, what an idiot. But you got to realize what's caused this particular problem. So here's what we do in terms of the actual process, right? So what we do, we use a simple process of tracking all the issues. So all the issues are saved as a simple viewpoint. Each one is in a folder dated when it was found, and then we've numbered them sequentially so we can keep track of the numbers. And then the manager or BIM coordinator reviews all the previous issues and closes them out if they're closed. And this is the key point. The engineers, the architects, and the coordinators are expected to refer to Navisworks on the CDE after each meeting to review the issues and amend their designs as agreed to resolve them. So the meeting notes and the coordination discussion is recorded and kept on the CDE. So there can never be an argument about what was discussed, who discussed, or whatever else. And if anybody wants to figure out what was discussed, they can go to the CDE and find out. So we make the model the center of the coordination process. And when you look at the actual system, you can go in and all the models, there's a specific location for these models, and you will see every single meeting has been recorded. And at any point in time, we can go back and look at the model and see what was discussed at that particular point in time. So we have a full record of all the coordination meetings and all the issues that were discussed, all the way through the design stages. So this can be very useful if you want to go back and look at the evolution of the design and what issues have been discussed and resolved. Now, one of the things we discovered is that because you have these models sitting on the servers, unless you open the model, you don't know what the issues are. So we found a piece of technology. Our problem, because don't forget, we want to solve problems with technology. We don't want to find problems to find technology. So our problem was we did not know in how many issues were in what station, and we did not know how many issues were assigned to what consultants. So what we discovered was there's a piece of software called BIM Collab, and BIM Collab is a cloud-based platform that connects to Navisworks, and you can link all the views that you have in Navisworks to the cloud platform. And then you can, as a manager, you can use a browser, so Chrome or whatever browser you prefer, and you can then go and see all the different clashes. And you can see who's been assigned a clash, and you can see what the comments were, you can see the clouds, and then you can track all the different issues across all the different stations. So in our case, what we were doing was we were looking at, on this graph, basically time chart. Each line is a station, and the graph is mapping out the number of issues on a station by station basis. And you can see they're going up and down, but they're generally trending from a high number on the left to a low number on the right, which means that the design is being resolved and issues being resolved. You'll notice that there are two lines that shoot for the sky at the end of this process. And what was discovered was that when we started doing the secondary detailing for shop drawings, and we started putting in cable trays, hangers, and pipe hangers, and other secondary supports into the models, we discovered that the MEP systems were not properly coordinated by the designers. So we basically found that unless we actually made the designers model all the major hanger systems, we were creating even more coordination problems. And you can see the scale. It goes from 15 to 16% issues all the way up to 60% issues. And what we're doing is we're measuring the number of issues on a square meterage basis so we can get some alignment. So we basically take the square meterage of the particular station and we count the number of issues per square meters, and that's how we get a percentage. So then the acceleration of issues is because of the increase of the amount of information in the models. So that's how we do our coordination. We basically have a process where people share the models on the CDE. We have a process where those models are checked. We have a process where those models are then reviewed in a meeting with a number of people that can make decisions. And then we record all those issues and we track them with these kind of dashboards. So that's how we do it. Does anybody in the group have an alternative way or another way of doing it that they want to share before I move on to the next topic? Or does anybody have any questions about what I've just shown you?
I have a question.
Great.
So the increase in number of clashes, that's never going to improve though, because each contractor has their own way of doing things, and during the design phase, you would never be able to guess, and it's not quite logical to guess. So then in the design phase, you're always designing to kind of a conventional, and then the clashes will come later.
Yes and no. So okay, so don't forget, this is a design and build contract. So in this situation, we are a management contractor, and we have appointed the AECOM consultants to produce buildable, coordinated models and drawings. And it's included in their scope of works that the definition of buildable is that we don't have to move pipework and cable tray and ductwork to allow for secondary supports and hanger systems. So in our opinion, they should have positioned the pipework and cable tray and ductwork in such an arrangement that we can thread hangers up and down between them. But the only way to actually determine if that's true or not is to actually put the hangers in. Now, the good news is there's some very simple tools you can buy as a plugin that you can put into Revit, and it will put in hangers at 1 meter centers indicatively, and then you can very quickly see where those hangers are clashing. So the thing is, we didn't put the hangers in. This is March 2018. We didn't start modeling the hangers till 18 months into the project, because we didn't see the benefit in doing it until that point. So we did not put the pressure on the consultants until the design was nearing completion. And once they started saying, oh yeah, our design's near enough buildable, then we said, okay, we need to check all of the secondary support systems. And it wasn't just the mechanical systems. We did that for the handrails, for the architecture, for the ceiling systems. I'll give you another example. The signage that hangs beneath the ceiling, some of the computerized signs are so heavy, they need proper structural frames. And when those structural frames are put up into the ceiling voids, they clashed with all the mechanical systems, electrical systems. So an architectural element that was below the ceiling was having a major coordination issue above the ceiling. So these were all lessons we learned from previous projects, but we chose when to put them in the models. And in some cases, we did the modeling to check what the consultants have produced. So this comes back to the BIM management. You want to know when you're going to model certain things and for what purpose and what level of coordination. So in our case, we wanted to make sure that we didn't have to take down pipework and cable trays and ductwork after we started installing them. more importantly, we wanted to make sure that all the openings in all the concrete walls were in the right place. Because if you start moving pipework and cable tray and ductwork, then all of a sudden the openings are all in the wrong place, and the openings get built first. So you end up casting concrete walls with openings, and then you end up moving the pipes and having to coring the walls. So it's not a case of if the consultant should model it, it's a case of when the consultant should model it, in my opinion. And it all comes back down to the BIM deliverables and BIM schedules. And the example I share with you guys in the PDF, it's on the contractor to solve this issue. And like I said before the coffee break, if the contractor sees that the pipework and the cable trays cannot be coordinated, and they're going to start clashing with things like ceilings, or they're going to have to get moved into spaces they shouldn't be in, then it has to go back to the design team to get resolved. And that's where it becomes an issue. If the design team are not able to or willing to solve the issues quickly, then BIM becomes a null and void point, and the problems are just going to turn up on site. Eventually, the architects and engineers are going to have to fix it. It's just a case of whether you fix it in a model or whether you fix it on site. So it's not a case of, there's two issues. One is defining what has to get modeled and why it's getting modeled. And the second question then is, once you figure that out, the question then is, when do you model it? And at what point in the design process does it get modeled? Does that help, Wendy?
Yes. Yes.
Okay, cool. Okay, any other questions about modeling and coordination? Because this is the main crux of BIM as it stands in the industry right now. Is anybody a different experience they want to share?
So I have another question if no one else, which is, I feel like, so we did a past project, and we were level 2. We use common BIM sharing space, a lot of the things you were talking about. But one problem we had was our project was very bespoke. So a lot of the components that we were looking at were not industry like available products. So a lot of times you have to solve a lot of the design issues as and when they appear. You don't really know. So in that case, it's very difficult for the model to be set up correctly from the early work stages. And it's even more difficult to like assume things like, oh, what structural support or, etc. And from listening to a lot of BIM lectures, I feel like perhaps BIM is very, very suitable for things that are already quite standardized. Whereas for very bespoke item, it's very, very challenging.
Okay, so the thing about that, Wendy, is I don't know what you mean by bespoke, but I'm guessing it's some kind of unique design or something unusual. In my experience, what you would be looking for in that situation is that the only way that kind of project gets built is if you're already talking to people who actually understand how it's going to get manufactured and installed. So, for example, I was involved in a project where it was a major sports facility in North America. It was in the US. And the architects were looking to install a very complicated cladding system around some parts of the main public spaces. And the design that they had, it was the principle was quite clear, but it was a metallic surface they wanted, but it was very broken up and it was very patterned, and they wanted to do certain things with the patterning, and they wanted to do certain things with lighting. It wasn't something you could readily model, and there was no point modeling it because we didn't know it was going to be manufactured. So the advice that we gave them as a BIM consultant at the time was, this is not a BIM problem, this is a manufacturing problem. And we urged them to find a manufacturer that had 3D digital manufacturing capabilities that could get involved in the project, either as a consultant on paid fees or as a nominated subcontractor that could actually do the work and develop the project going forward. So this goes back to this notion of early contractor involvement. You can model anything you like in 3 dimensions. You can take out something like SketchUp, you can take out something like Rhino, and even now Revit's got some pretty powerful modeling tools. You can create whatever 3D geometry you like. But if you don't know how it's going to get manufactured and how it's going to get installed and what sequence that's going to happen in, you can't really do any detailed design or any detailed coordination. And the only way to solve that problem is early contractor involvement or early supply chain involvement. So if you're doing a bespoke project and those objects are not normal, yes, there's limitations in current libraries of models, but you can be sure that if you find the right supply chain, you will solve those problems. What was the bespoke thing that you were doing, Wendy, just out of curiosity?
We're doing a hotel in London, and we have very bespoke facade system, and the interior design, you know, the client didn't want anything off the, you know, available market. So all items were literally bespoke. We had to model every single component family. We used nothing from existing libraries, and that was not fun.
I hope you charge them a lot of money for that.